Okay, a few notes. Eyes up here, please. I had hoped that I would have lab books to give you today. I don't, because they haven't arrived yet. They may arrive later today, in which case we'll hand them out. We're definitely doing a lab this week. It looks now like it'll be Thursday rather than tomorrow. But we will definitely get a lab in this week, even if I have to push it to Friday, as soon as the books arrive. Yes?
The football players aren't going to be here for the second half of the
Which day?
Thursday.
Okay, then we'll do it Friday. Thank you for the heads up. I appreciate that.
I will be here too.
Okay, okay, we'll get there. So, shh, listen up. Anyway, look here. This doesn't affect you yet because you don't have a lab book, but once you have a lab book, I've put the first lab activity online. It'll be our habit once we get going that we're going to put those lab preps into our lab book. Once we have the books, I'll talk about how we do that, okay? But I just wanted to put up that if you want to take a look and give it a brief once over, give it a read, you can do so. Shh, I feel disinclined to speak over people, please. Thank you. So that was my first point, which is that we're going to get going on labs. I'm kind of annoyed that's taking this long. I ordered books at the end of last year and they still haven't come. But I don't want to start doing them on loose leaves of paper, A, because I want to give you kind of an authentic experience, and B, because when there's loose papers flying around, I do exactly one thing with them, which is
Garbage.
lose. If you said lose them, then you are correct. I'm a bit of a, what do you call somebody who loses things? I guess a loser would be right, and that's me. So I prefer to have you work out of one book that I will have a much harder time losing. Now, yesterday we reviewed the Crisscross Rule. I left you with some homework. Questions from homework, ones that we want to check up on. Yeah. By the way, I had mentioned in class that if it had a little Roman numeral on it, we weren't going to worry about it yet. If you remembered how, that's great. But if you didn't, yeah, you certainly may well have. So questions from the homework. Yes?
Number 2.
Number 2, okay. Let's do that. So barium nitride. So when we're doing the crisscross rule, what's the first thing we do?
Write it down.
We write down these symbols, right? What's the symbol for barium? Ba. Now, what do I put with that? +2. Why do I write +2 next to it? That's its charge. How do you know that's its charge? Good. It's in group 2. Does everyone follow that? Because it's in group 2, we know it has 2 electrons in its outer shell, so when it loses those, it will have a charge of +2. Good. Nitride. What's that going to give me? What's the symbol for it? This table. I want this table. Symbol for nitride. N. Good. And what charge does N take? Yes, sir. -3. Good. How did you know that? Yeah, okay. So if we look, nitrogen is here in group 15. To get a full shell, it'll have to go all the way as if it were in group 18, right? It's going to have to gain 1, 2, 3 more electrons, right? You could say that in its outer shell, it has 5 electrons right now, and eventually it's going to need to have 3 more for a total of 8 to achieve a full second shell. Okay, once I have those written with the charges, what do I do next? Yeah, meaning what? What do I do next? Well, that's okay. Let's say you're wrong. Worst case scenario. You're wrong. I'm wrong like 18 times a day from the front of the room. But I just don't.
Crisscross.
Good. So how do I do that? What should I write on my next line?
The same BAN.
So the BA again, and the N again, and then what do I do?
Throw the 3 over there and the 2 over there.
Good. Do I take the negative sign and the positive sign with it?
No.
Do I?
I don't.
That's right. Because again, we're not really. Why do we do this again? Because it works. Because it's fast. It's a trick. It's what we call an algorithm. Doing this will help us to figure this out. If I didn't use this method, how would I have to figure out what the ratio is? Remember what we did in the second half of yesterday's lesson to show you the full method? What did we do? We drew it, we drew Lewis diagrams, and we physically moved over the electrons, right? Until we had a case where everything on the page had full shells or empty shells. Remember that? Okay, so this trick works quicker than that, obviously. And what formula does that leave us with for barium nitride? Yeah? It's not a trick, I promise. Very good. All right, and that means when these two things come together, first of all, what do we call it when a metal and a non-metal come together to form an ionic compound? We call that a binary compound. Good. When barium and nitrogen come together to form barium nitride, which is a binary compound, what does that number tell us, that 3 and that 2? Yes?
There's 3 barium from 2 nitrogen.
Good. How do these arrange themselves? You'll worry more about this next year. But does anyone know how binary compounds arrange themselves? They always form. If we had some back then, I went and got it. What would it look like? All of the binary compounds, they're quite boring. They all make crystals, typically little white crystals. And what this tells you is that in that crystal structure, for every 3 barium, there's 2 nitrogen. All right, so they're all stuck together, but in a very fixed ratio. And it can only ever be that ratio. That's why when we name it, by the way, I don't need to say that it's tribarium dinitride, right? I don't need to tell you that because if I tell you that barium and nitrogen come together, if I tell you that a metal and a non-metal come together, it can only come together one way. There's only one way you can put them together. Ionic compounds are very boring. There's no creativity involved. There's only one way to put them together. Other questions from the homework? Maybe do 1 or 2 more? Yeah, question. Yeah.
If they're both the same, they just you don't have to write that, do you?
That's a good question. So let's look at one that is like that. This next one's perfect, actually, calcium oxide. Sarah, what would I write as my next line for this?
Ca.
Yeah, and what charge does it take?
I think so.
Maybe 2?
Yeah, what group is it in? Yeah, it's in group 2, so it'll take a 2+ charge. And what about oxygen? What group's oxygen in? Yeah, it's in group 6. It's got 6 electrons in its outer shell. How many does it have to gain? 2. So it'll have a charge of what? 2. Very good. So now what would my next line be, Sarah?
CaO.
Good. So I'm going to write that again. And when we cross it over, I was hoping somebody would ask this question. What numbers are going to go down there, obviously? The 2 comes here. The 2 goes there. But the answer to this question isn't Ca2O2, is it? What's the answer? CaO. So we can always do what with any of these? We can make sure that we simplify. We can always simplify. And Sarah, thank you for asking that question. I was worried I was going to have to ask it myself and then answer it. And that's always less exciting. Okay, were there any other questions from the homework that people wanted to go through? No? Don't be shy, because my expectation once we move on from this is that you know it, right? So if there's a question you struggled with, now's a good time to ask. Okay, so everybody here is super comfortable with diatomic compounds, with binary compounds. Okay, eyes up here. We are going to then today start talking about special cases. Special cases. All right, so today's lesson has the rather exciting title, Other Ionic Compounds, Part 1. This is going to be like a Peter Jackson movie. I could get it done in 1, but I'm going to drag it out to 3. Jackson director. You got this. Hobbit should have been 1 movie. I'm just saying.
Well, the second movie of did was very fast.
Yeah, no, it's true. I could even see doing 2, but 3 was ridiculous. The problem is this: it's a kid's book. It's a kid. It didn't need to be. It's not the Lord of the Rings. Anyway, I digress. We can talk about all things Tolkien later. He did make lots of money. Yeah, I mean, the 3rd movie, just to be clear, was not a movie. It was a scene. It was a big, long, extended scene. Anyway, okay. So, we have talked about naming binary compounds. Very straightforward, right? The name of the metal. Okay. So we talked about naming simple binary compounds, which is a single metal and a non-metal that come together. We know how to come up with their formula. We use what rule? Crisscross Rule, which you're going to do to death in this course. And then we know how to name them as well, right? So if I put calcium and sulfur together, what would the name of the binary compound be? Nice and loud. Be bold.
Calcium sulfide.
Calcium sulfide. Because how do we name a binary compound? Yeah, and what do we do with the metal? Keep it the same. And which one comes first? Yeah. So we put the name of the metal first, in this case calcium. And the second thing that comes is sulfur, but we change the ending to I, and we're done. Always I. If it ends in I, it's a binary compound. If it's a binary compound, its name will end with I. Always. It's always true, there's no exceptions.
What's with the nitrate?
You could have asked another question, but that's what we're going to talk about right now. Sometimes we see, now, if I said calcium nitride, you would know that that was a binary compound of calcium and nitrogen. And you would know that you could use the crisscross rule, right? And so we would look and we would say that calcium has a charge of 2, nitrogen has a charge of 3, and after we crisscross it, we would say that it's Ca3N2, right? Easy, quick, grade 10 work, we know how to do it. Did our homework yesterday, nobody had any other questions, so I assume we're experts at it, right? Okay, but sometimes we see something called calcium nitrate, or maybe calcium nitrite, or you're going to learn about a few other ones. What are those? Does anyone remember? You did talk about them last year, but you didn't have to know too much about them. Yep. Good. Polyatomic ions, also known as polyatomic ions, and we also call them radicals. Okay. What is a polyatomic ion? Break the word down for me. Do we have any budding linguists in the room? Poly, you're thinking like polygon and something like that. What does poly mean? Many, many, more than one. Good. So poly means many. What does atomic mean? Atoms, many atoms. And then what does ion mean? What's an ion? Yeah, we think of an ion as being an atom that has a charge. By the way, how can an ion get a charge? How do we start with a neutral atom and make it charged? What can we do? Yeah? Losing and gaining electrons. Good. We could take an electron away from it. By the way, what would we have to apply to make that happen? Yeah, what kind of energy? Spot on. Good. So if we provide the ionization energy, we can remove an electron. Or we could add an electron. What would that do, by the way? This is just reminding us. If we added an electron to it?
It would cause like the atom to release electron affinity.
Right. It would cause the atom to release energy, which we call the electron affinity. Good. So those are the two ways we can make an atom an ion. Okay? But a polyatomic ion is an ion made up of a group of atoms already bound together. Okay? So let's write that. A radical All right, now, does that definition confuse anyone else? I hope not. But to give an easier one, another way of saying this would be, it's an ion made up of more than one atom. All right, those are just two ways of saying the same thing. Yes?
That A with the slash, is that just you start and the thing goes slash?
That's supposed to be an arrow. I'm sorry.
Okay, just check.
No, that's a good question.
No, above it, above it.
Where? Oh, that's a dash. That's just me being messy.
There we go.
There you go.
I just thought it was negative
Okay.
something.
No, it wasn't at negative A. I'm sorry. Okay, what's an example of a polyatomic ion? Can anyone think of one? Something, yep. Ammonium, good. Do you remember the formula of it? Oh, that's a different one actually, but that's okay. Do you know what we call OH minus? Hydroxide is right. We mentioned ammonium. Does anyone remember what that is? It's the other one. NH4, and what's its charge?
Positive.
Positive, yeah. Ammonia is NH3. Ammonium is the ionic form of it, which is NH4 plus. Okay, now there's some good news and there's some bad news. The good news is these are really easy to name once you know the names of all the common radicals. Because you just say the name of the metal and then the name of the radical it's with, or the name of the radical and the name of the nonmetal it's with. The bad news is we're going to have to learn all of the common names for these things. So let's talk about naming common radicals. Okay, leave a little bit of space like I've left here. And I'm going to use an example here. Which is CO3. And that has a 2- charge. Okay. Does anyone know what CO3 with a -2 charge is called? Maybe you remember it from last year. It's called carbon Carbonate. Okay. The most common form of radical, are these non-metal oxides. Ah, that sounds complicated, but what do we really mean by that? What's a non-metal? Not the metalloids, but the straight up non-metals. Where do we find them on the periodic table? On the right. So any of the things on the right can combine with oxygen to form these radicals, to form these groups of atoms that always stick together and have a charge. Okay. So CO3 is called carbonate. What do you think we'd call ClO3? Yeah, somebody said. Chlorate. Chlorinate is a good guess, but it's actually easier than that. It's chlorate. There's nothing wrong with being wrong. That's what we're trying to do here. And it has a charge of -1. What do you think I would call NO3? And it has a charge of -1 as well. What would we call that? What is it? Nitrate. Good. What are the other 3 ones? Yeah, okay. What do you think I would call BrO3? Yeah, bromate. And that has a charge of -1 as well. Okay. What would I call IO3? This one's tough to say. See if you can figure it out. Iodate. Iodate. Good. Okay, and 2 more that we're going to learn. Now, quickly here, what do you notice? All the other ones have been, all of them, oh, sorry, this does have a negative charge. All of the other ones have been CO3, ClO3, NO3, BrO3, IO3. This one is SO4. But the naming remains the same, and we would call it, good, sulfate. By the way, if you spell it with a PH, that's the British spelling. I will never mark you wrong. Typically, in the American spelling, it's the F, and that is actually accepted as the international standard. There's a company called IUPAC, the International Union of whatever, I can't remember what it stands for, but they're in charge of deciding on standard names for things. They accept it with, they prefer it with an F. I will accept either, F or PH. All right, and the last one is PO4, and this one actually has a charge of -3. And what do you suppose we call it? Phosphate. Okay. Now, look at that list. We have carbonate, chlorate, nitrate, bromate, iodate, sulfate, and phosphate. These are the base formulas. Yes. No, the order doesn't really matter, but do go across like I have, because we're going to build up and we're going to build down. Okay, it's the base formula, and the names always end in 8. Okay, now, I want to explain where this naming system comes from, because it's an older one. Basically, in the early days of chemistry, they discovered all of these first and relatively early, because these are the most common polyatomic ions for each of these. So the most common polyatomic ion that carbon makes is CO3 with a charge of 2 minus. And so they called that carbonate. And the most common one for chlorine was ClO3. And it would have a charge of -1. And it was called chlorate. And they found all of these most common ones first. In fact, in nature, how we find carbon, chlorine, nitrogen, bromine, iodine, sulfur, and phosphorus, often in nature, is in these kinds of compounds. It tends to react with oxygen first, and then with a metal later. And a lot of the ores and rocks that you dig up that contain these different non-metals actually come in these forms. Now, the reason I'm mentioning this is this. Carbon most commonly will react with 3 oxygens to form an ion. But sometimes it doesn't. Sometimes it reacts with 2. Or sometimes it reacts with 1. Or sometimes it might even react with 4. And guess what? All of those have a different name. They all have a different name. So we're going to learn how they get named. But the trick to the whole thing is this row here, is the base formulas. It is not often I will make you memorize things in class because I don't think it matters much. But in this case, we are going to deal with these names so often, I'm going to make you learn how to do this naming system from memory. From memory, which is a new addition for this year. And it takes some practice. Don't worry, you'll get lots of practice. So the base formula is the most commonly occurring version of each of these polyatomic ions. So, actually, I'm going to do that one second. Let's go below first. Okay. So we said that, oh, geez, here we go again. Okay, so follow me here. We're going to try to come up with this together. So we said most commonly in nature, when carbon forms a radical, when carbon forms a polyatomic ion, it does it with how many oxygens? Normally, 3. And what do we call that? Carbonate. Good. So carbon will often form a radical with 3 other oxygens, and when it does, it has a charge of -2, and it's called carbonate. But sometimes carbon can form a radical not with 3 oxygens, but with 2. Okay. Now here's what at least makes it a little easy. Do you think the charge changes? It does not. The charge is always going to remain the same, which is nice. By the way, if you take the grade 12 chemistry, you'll figure out how these all work. For the 11 chemistry, I don't need you to. We're just going to memorize the naming for now. What do you think we name it? Not carbonate, but Star Wars fans? Carbonite. Very good. Carbonite. Okay. Oh, okay. Okay. I'm sorry I said it. Now, again, normally in nature, what is the base formula for a radical of chlorine? How do we normally find it? Good. So it would have a formula of ClO3. What charge does it normally have? -1. Good. And what do we call that normal version? Chlorate. Good. But sometimes it will form a radical with 2. What would its formula now be? That's its name, but what's its formula? ClO2 -1. And you said it completely right. What will its name be? Chlorite. Good. So what I'd like you to do is take 2 minutes and see if you can fill the rest of this row in. Okay? See if you can do the same for nitrogen, bromine, iodine, sulfur, and phosphor. See if you can fill that row in, please. Not sulfate, but sulfur. Great, and then 1 pure oxygen to the base formula of sulfur.
Good. You got there?
Yeah. You know what? It makes no difference. Which is in white would be better for the standard. Unfortunately, both are acceptable. And as a result, I have yeah, it makes 0 difference.
So that should be consistent, just not be.
That's a good question. I'll try to be mindful. Yes. Is that 3? Yeah. Then we're good. And I like it. What? Good. Okay. So really quickly, what do we call this one then? If nitrogen normally forms an ionic radical with 3 oxygens, here would be if it formed it with far too exciting. I want to keep this very boring. Okay. What charge would it take? -1. And what would we call it? Nitrite. Good. What about bromine? It would be? Okay. Great. And its name would be? Bromite. Good. What about iodine? Great, and it would be called iodite. Good. What about sulfur? SO3, 2-, and it would be called sulfite. And the last one, yeah, and its name would be phosphite. Okay. Good. Okay, I hope that seems relatively straightforward. Now, what do you suppose the next possibility is? Yeah, so instead of 1 fewer oxygen, which these end in "ite", by the way, the next possibility would be okay, so now, eyes up here. Again, normally carbon forms a radical with 3 oxygen, but in this case, instead of 3, it would form it with just 1. Its formula would therefore be CO, and its charge would be? Yeah. Okay, and we would call that, does anyone know? Has anyone seen this before? Okay, let me ask you this. Is anyone here diabetic? That was very funny. Anyway, if your blood sugar is too high, what do we say somebody is? Does anyone know? Well, let me ask you this. If your blood pressure is too high, what do we say somebody is? Has anyone heard the term hypertension before? No, eh? Okay, hypertension means there's too much tension in your blood vessels, i.e. your blood pressure is too high. Too high, hypertension. Somebody who has too much blood sugar has hyperglycemia. Hyperglycemia, too much blood sugar. What do we call a kid who's running around way too much? Hyperactive. Good. Too much activity. They're doing too much. So the prefix hyper means what? Too much. It means more. It means lots. Does that apply to this naming right here? No. What's the opposite of hyper? Yeah, nice and loud. Not diaper. No. Good. That was a poor guess, but that's okay. I like guesses. Nice and loud. Be bold.
Hypo.
Hypo. Hypo means the opposite. If you have hypotension, you have low blood pressure. If you have hypoglycemia, you have low blood sugar. If a child is hypoactive, I don't think anyone has ever said that, because there's never been a time where you wanted a kid to be more active. I can tell you as a parent, like, the closer to unconscious your children are, the happier you are. And then there's these blessed, wonderful parts of the day where they actually are unconscious, and that's great. That's just so lovely.
This sounds pretty murderous.
No, I'm talking about sleep, for God's sake. Sleep. Okay. Anyway, eyes up here. Okay. Eyes up here. So we call this, we now have to add a prefix, meaning even less oxygen. And the prefix we're adding is hypo. So this will be called hypocarbon. Good. Hypocarbonite. That's a terrible name. There's no two ways around it. I can zoom in on that a bit, because I know I wrote it small. Hypocarbonite. That means one less oxygen than even carbonite. Okay, what's the next one going to be? Formula and name. Put a hand up for me. Yeah. Good. Hypochlorite. Good. Good. So again, I want you to take a minute and fill the rest of that chart out, please. I'm going to have a fun time fitting in that next space. I can cover all that.
So in a standard form, that's how many? Yes. And so here's that group that we're running, and it would be Hypo. Okay, yeah, just make sure it's T. That was all fine. And for you, same thing, I don't know what these then this should be those are the sulfite and phosphite. Sulfur and phosphate are all that one word. Okay, the only thing I don't like is those 4 oxygens for 3, and this one should have 2 fewer, but you have it having only 1. It should have
right? But SO4, SO3, this should be SO. So it's just sulfur and phosphor are always the funky ones. They always have one more than all the others. They never go everywhere. You'll never see SO. The lowest they go to. Yeah, oh, for sure. Absolutely. Okay, so really quickly, what will the name of this next one be? The name of it. Hypo Nitrite. It's going to fit. I swear it's going to fit. Okay, there we go. And its formula will be what? And its charge? -1. Okay. What will the next one be? Hypobromite. Good. And its charge? Well, it's BRO -1. Good. What about hypoiodite? Good. That's got to be the hardest thing to say I can think of right now. Hypoiodite. Okay, now this one here is tricky. What will the name of this next one be? Hyposulfite. And its formula is SO2 with a charge of -2. Good. And the last one? And what will its formula be? Like that? But neater, hopefully, on yours. Okay. Are we done? No, I left a space above because it's also possible to have, yeah, we can also have one more oxygen. Okay, now if hypo meant one fewer, then up above should give us hyper. So can somebody tell me the formula and the name of the next one above? Yeah, Rain.
Formula CO4 with a charge -2.
Excellent.
And we'll call it hypercarbonate.
Hypercarbonate is exactly right. Good. Okay. What's going to be the next one?
ClO4 with charge -1.
Good. Hyperchlorate is good. Somebody else give me the next one? Yes, sir.
It'd be NO4, charge -1. It'd be Hypo Nitrite.
Good. Can somebody else give me the next one? Grace. We are on bromine.
You wrote night on the.
Did I? Thank you. This is where I go, I was just seeing who was paying attention. But I just screwed up because I do that a lot. But Grace was paying attention, and we're glad for it. This is bromate. And what's its formula?
BRO4.
Good. And its charge? People can volunteer themselves. Well, that's okay. That's his prerogative. I'm not in the business of making people do things. But if somebody would like to volunteer, that'd be wonderful. Someone new? Yes. Iodine.
IO4.
IO4.
-1.
Yep.
And the hyperiodate.
Hyperiodate. Good. Okay, next one. Someone new. Alpha? No, okay, that's fine. No, I don't. That's fine. You can pass. You can you can always pass. You just look at me and say, "Joe, go away." Nobody likes you, and I will. I'll move on. Okay.
I'm gonna call you Joe.
You may not.
You said it.
I'll fight you. Okay. Can somebody give me the next two, please? I want to move on. Come on. Come on. Yes.
Okay, so it's SO5, charge -1. And it's
-2.
2.
Yep.
I'll put that down wrong.
That's okay.
And then that would be hypersulfite.
Hypersulfate. Good. And the last example, please. Yes, sir.
PO5,
Yeah.
the charge of -3.
Good.
That's going to be hyperphosphate.
Good. Okay. There we go. Now, that's a big ugly table, and yeah, I'm expecting you to know the whole thing over the next week or so. Now, the bad news is that table's a pain in the butt to remember. You can come up with some basic, simple devices. It's easy. The trick to the whole thing, guys, is don't try to memorize the whole thing. You'll go insane. Memorize the bases. Know what all of the standard ones are, all of the 8 ones, and then know how to move up or down based on how many oxygens are, okay? If you try to memorize the whole thing, you'll go insane. So focus on memorizing the base formulas and then working from that, all right? So you should know that CO3, ClO3, NO3, BrO3, IO3, what are the only 2 that aren't 3 in the base?
Sulfate and phosphate.
Great, and they're both 4. Good. Now, the good news that I talked about is that once you have this, once you know this, working with it is very easy. How do we still use the crisscross rule. All right, the crisscross rule still applies. So let's look at a simple example. Okay, when I first look at this, how do I instantly know that it's got a polyatomic ion, that's got a radical? This one is ITE, but good. What does it not have? Good. When you see that it doesn't end in "ide," then you know that it must have a radical. If it ends in "ate" or "ite," then it has a radical. That's very important. So now, to use the crisscross rule, what has always been the first step using the crisscross rule? What do? We write the formulas. Good. What's the formula for calcium? No, that's chlorine. Calcium is?
Ca.
Ca. Good. No, don't give up. That's good. What's the charge on calcium? 2+. Good. And then, what's the formula for bromite? Well, bromate is the base, and that would have a formula of BrO3. Ite means it has 1 less oxygen, so it would be BrO2. And then if you're not sure about the charge, for now, you can go up and check. Eventually, you'll have them all memorized. And bromite takes a charge of -1. So we do what we've always done. We write the formulas out with the charges. What's my next step? I write the same thing below. So Ca and BrO2. Okay. Now what do? I am actually. That's I not net. I wasn't going to do that next, but I could. We could put a bracket around it, sure. And then what do?
Crisscross.
Crisscross. Good. So the 2 is going to come down here, and the 1 is going to go there. And as a result, I'll have Ca1 and BrO2, 2. Now, you beat me to the punch because I was going to make a note. No, that's good. That's God, it's really good to beat me to the punch because I forget stuff a lot. But here's the note. If we have to leave a number, next to a radical, what do I have to add? I have to add brackets. Good. Why? Why does that matter? Yes?
Is it so like you don't like accident? Well, I'm just
Yeah, no, that's good.
you don't accidentally like do the oxide.
That's right. If I didn't put brackets, when I came back and looked at it later, it would look like 1 calcium goes with 1 bromine and 22 oxygens. Is that what I want to say? No, it's not. So we put a bracket around it to say that there's 2 of the BrO2s. In other words, there's 2 bromines, and how many oxygens would there actually be there? 4. Good. Okay, and when we put this together, we get what? Calcium bromite, and its formula is Ca bracket BrO2, 2. Good. And there it is. All right, in the time that remains, I want you to do one more example. Okay, so yeah, I haven't done this in a while. Okay, strontium hyponitrite. Go ahead and work on that, please. Use the crisscross rule and give me the formula of strontium hyponitrite.
Isn't it +5? +5. Yeah, but it's in number.
What group is strontium in? Group 2, so it must take a charge down.
Oh, I still had it back.
Woo!
Maybe a +2?
Yeah. SR. Yeah. Okay. Those are both true. They're both true. This one, that's cut. I know what the actual radical is. This is wrong. The problem is this, I can replace 0 for that. The hypo. And I know that is. Oh, that's right. Base of nitrate. But again, okay, guys, really quickly to use the crisscross rule on this. And again, I cannot stress enough, as we move on in this course, you will use the crisscross rule with things like this all the time. In a couple of weeks, I will give you problems where I say 3 grams of strontium hyponitrate react with 2 grams of iron chromate. And I won't give you formulas. I will expect you to just be able to put those formulas in. All right, so you have to get this skill. You have to. What do I write here?
Plus 2 times 2 positive 2.
Okay, good. Strontium takes a charge of +2. Good. What is Hypo Nitrite? Yes, sir. Good. NO -1. And again, remember, hey, Zenka, eyes up here. Don't ask me what's up. My frustration levels. No, it's fine. Look here. Remember that the base formula of nitrate is NO3. So hyponitrite would be 2 less. And that gives us NO with a charge of -1. What do I do with these next? Yeah, we rewrite them and then we crisscross. And when I do that, what do I get? Yeah, and because that 2's there, what do I have to use? Yeah, so we're going to put 1, and we're going to put brackets around this now, and then put 2. And so what's my final formula? Yeah. And just remember, be very mindful of those brackets, because this is not the same thing. Don't write this. This isn't, even I can't write it. These are not the same thing, are they? Those are different things. Those brackets are important. Okay. Here's your homework. You are to name, use this chart, use your periodic table. You are to make 10 ionic compounds made up of a metal and a radical of your choice, and then use the crisscross rule to come up with the formula.
Just 10 of our own?
Any 10, any combinations you like, you're going to hand them in to me tomorrow. Okay? Oh, yeah, you're handing them in. So your homework, so name and give formulas showing the crisscross rule for 10 ionic compounds with radicals. And I'm putting 2 exclamation marks to show that I think that homework is exciting and important. And then I put the other 2 upside down at the front because I was feeling very Spanish today. There you go. I did not. It's just how they do it. Yeah, it's just grammatically how they do it. You took Spanish. Do you speak any?
I got 32 on my exam.
Ah.
So, not very well.
Good to know. All right, guys, thank you very much. I'll see you tomorrow. Hopefully you completed a quiz today in MSIP. If you did not, make sure you do. Yes. Yeah. Yeah, come take a look.
Okay.
Give me 2 seconds.
I passed.
I'm coming there.
Yeah, you come to me.